Hi everyone, my name is Gina, and in this video I'm going to go through a review of file I/O in C++. Specifically, I'm going to go through how you can read line by line from an input file, how you can read word by word from each line in the input file, and I'm even going to show you how you can read character by character from each word from each line in an input file. So let's get started. To do this, I'm going to use my Linux virtual machine running Ubuntu, and I'm going to use the gedit, very simple text editor, in order to edit my C++ code. So I'm going to make a main.cpp and open it up in gedit. If you've never used gedit before, let me show you a few little preferences I like to set in order to make it a little bit more bearable as a simple text editor. So hit this kind of overflow menu icon or this hamburger icon, go to preferences, and here's a few things that I highly recommend you set. First off, check this box to display line numbers. If we have a compiler error, the compiler is going to give us a line number where we should start looking for our syntax error. We want to be able to easily find those lines. Next, let's come down to the bottom, and under highlighting, let's choose highlight current line and highlight matching brackets. Under editor, let's change the tab width from 8 to 4 spaces. And let's also check the enable automatic indentation box. You don't need to do this next step, but I'm going to do it so that it's easier for you to see my code. I'm going to head over to fonts and colors, uncheck this box, and then change the editor font to use much larger font. That way it's easier for you to see the code that I write. All right, this looks great. Especially now we can see the line number and we can see the line that we're currently working with. It's kind of this darker gray background right here. So let's get some boilerplate C++ code up and running for our main method or our main function. There's going to be 3 libraries I'm going to use in order to solve this problem: ifstream, fstream, and sstream. So ifstream is for things like cin and cout. Fstream is for things like ifstream and ofstream for reading from and writing to files. And sstream is for things like istringstream and ostringstream for reading from and writing to strings. All of these work with streams, so we can use them fairly interchangeably, even though their data sources are different. IOStream is working with, say, things like the keyboard. Fstream is working with things, say, like files on the system. And then sstream is working with things like strings. All right, so let's make our input file, and then I'll go into more detail about what we're going to try and do by reading from this input file. So let's make one more file. So I'm going to head back over to the terminal. I could also do this in gedit. And I'm going to launch gedit again, this time opening a file called sentence.txt, which doesn't exist, but it'll be created. So sentence.txt is going to be our input file. What we need to put in here is really just something to read, but what we really need is multiple lines and multiple words on each line. That way it gives us something kind of variable to work with. So I'm going to use this very traditional English sentence. I'll do the quick brown fox jumps over the lazy dog. Okay, just write some sentence, make sure you have multiple lines, and make sure each line has multiple words with some different number of words per line. So our goal is to read through each line in the file and print it out to the console. We'll do that first. And then within each line, we want to read each word and print each word out on its own line to the console. And then lastly, within each word, we're going to read each character and print out each character one at a time to the console. So we'll be drilling down from the line to the word to the character level. So like this first line has 3 words, and within the first word, there's 3 characters. So we'll see T, H, E, all on its own line. All right, so let's start with first things first. We need to open the file and make sure we can successfully open it. So back in main.cpp, let's take some notes here about the 3 steps in order to process any file. It starts first with open the file. After we open the file, we'll process the file. That's reading for an input file and writing for an output file. And then the last one will be close the file. All right, so for opening the file, we'll need an ifstream reference. The I is for input because we're going to be reading. I'll call this in-file. And let's call a function called openFile. We'll pass in our reference to our ifstream to open and the name of the file we want to open, which is sentence.txt. Double check and make sure that you spell this exactly as you spelled it when you created the file, and double check by heading over to your terminal and running ls that this file, sentence.txt, is in the same directory as main.cpp. So make sure those are in the same directory. All right, we'll need a prototype for this function. It's not going to return a value, so I'm just going to set void as its return type. It's going to accept an ifstream reference. Okay, whenever we're passing in ifstreams or ofstreams into functions, we need to pass them by reference. And there's actually a second argument here, a string representing the name of the file to open. All right, so here we're going to open in-file. We'll use fname as the name of the file to open. One quick thing to note here is sentence.txt. This is a relative path. It's a relative path because it doesn't start with root. So this file has to be in the same folder as main.cpp because we're using a relative path, which is relative to the current working directory. I'll show you an example here quickly of an absolute path. The pwd command will tell you the present or the current working directory that your terminal is operating in. So /home/Gina is my present working directory. And this path right here starts with root, which is the very top of your file system. It's like the C drive if you're coming from a Windows background. So absolute paths start with root. This is an absolute path. This is not an absolute path. It's a relative path because it doesn't start with root. All right, so just double check and make sure that sentence.txt is spelled this exact way and it's in the same folder as this main.cpp file that you're working with. If those two things are for sure okay, then you should be able to successfully open the file. It's always good practice though to check and make sure that you are able to successfully open the file before you continue on and use that ifstream reference that you think is open. So let's check. If infile.isOpen, this will return true if the file is open, false otherwise. Let's just say something like successfully opened file. If this returns false, then we were not able to open the file for some reason. So let's just say something like failed to open file. And if we can't open the file, there's not much use in carrying on with this program. So I'm just going to type exit -1, call exit, which will terminate this program. There's no need to keep executing. If we can't open the file, there's nothing to do. So this isn't best practice per se, but it's fine for us because we're not going to try and recover if we can't find the file. All right, so let's test our code. We'll head over to G++, compile our code, and we'll run it. Hopefully you see successfully open file. If you see failed to open file, it's probably one of two things. Double check the spelling and double check that you made that input file, sentence.txt, in the same folder as this main.cpp that you're editing. All right, now we're ready to process the file. Before we forget, it's always a good idea to close the file once we've opened it. And this is only a one-liner, so not too bad to do. All right, so let's call a function called process file. Add a prototype and add a definition for process file. We don't need the name of the file for this function because we've already opened the file. All right, so in here, we're going to do three things. First, we're going to read line by line from the file. Okay, we'll read line by line from the file and we'll print out each line to the console. So we'll see in the console or the terminal this same structure that we put in here. The quick brown will be on its own line, fox jumps will be on its own line, over will be on its own line, the lazy will be on its own line, and dog will be on its own line. All right, so I'm going to need a string variable to store the line. And now kind of the classic loop for processing a file when we don't know how many lines are in the file or how many tokens are in the file is using a while loop. And this while loop is while not in file.eof. And EOF is the name of a function. It stands for end of file. And it returns true when we've reached the end of the file, meaning there's no more lines or no more tokens to process. So when this returns true, we've reached the end of the file. So while that's not true, while we haven't reached the end of the file, we're going to keep processing it. All right, so what we're going to do is we're going to call a function called getLine, which accepts input stream. So we could pass in cin if we wanted to. If we wanted to read a line from keyboard, standard in. We want to read a line from infile. So I'm going to pass in infile. And then the name of a string variable where getLine can put the line it read from the file. Okay, so it's going to read everything up until it encounters a new line, and then it'll stop. It's going to put that line into our string variable called line and discard the new line character. So each iteration of this loop is going to read one line, the whole thing. So let's make sure that we successfully were able to read a line from the file. We'll call infile.good. Reasons why infile.good might return false would be we have reached the end of the file and there's nothing else to process, or maybe something abruptly happened and we lost a connection to the file. Just always good practice to make sure that everything went successfully. So if we get here, we're going to see out the line. And now I can see the contents of sentence.txt showing up over here in the terminal. If I were to change this structure, maybe I'll only have 4 lines instead of 5 lines. Save the file, rerun the program, it's going to update accordingly. This is kind of a fun little program because we essentially wrote our own little version of the cat command or the cat utility. If I run cat sentence.txt, I can see the contents of the file line by line as well. So we already wrote our own little version of a Linux utility. All right, we just read line by line from the file. Okay, each line will be stored at some point in this string variable called line while this while loop executes. So now the next thing that we want to do is comment out this cout statement, and we want to read word by word from the line. That's our next goal, so that we can see the on its own line and then quick, brown, fox jumps over the lazy dog. Okay, so we want to see each one of these words on its own line, which means we can access the word by itself from the line. Right now, these words are in the whole line. We can't grab them individually. We're going to work on that next. All right, in order to do this, we're going to need another string variable. let's call it word. Okay, word is going to take on each word in each line. So just the way I said that, you can probably guess we're going to have a nested loop here. We're going to need another variable called an istringstream. You can think about this like an ifstream or like cin. We use it when we want to process a string. And that's exactly what we want to do, right? We've got this string here, line, and we want to process it just like we would process, say, from cin or from an ifstream. So 2 lines of code we need to write in order to prepare processing line using an istringstream. So let's do iss.clear. This is going to clear out the state. Okay, so note that we're inside of a loop here, right? Inside of while not in file.uf. So iss is going to get reused every single iteration of the loop. We're going to want to clear out its state from previous iteration of the loop. Next, we're going to want to copy in the string for iss to stream from. So let's copy in line. And now we're going to have a loop. And we'll have while iss.good. So while the state of the string stream is good, note that we're not going to use EOF here because we're not working with a file. EOF stands for end of file. We're not working with a file here, we're working with a stream. All right, so while iss.good, we'll use iss and the stream extraction operator to extract a word from our line, which iss is set up to stream from. So let's save and let's run. And now we can see that we can access each word individually. Now you've probably seen something that looks like this before, right? With cin, for example, we could get a word from the user. If we use this directly, we would have been able to get this output because the stream extraction operator tokenizes or parses input based on white space characters like blanks, tabs, new lines, etc. So we could have got this output without using getLine, but then we wouldn't have known when we were crossing a new line character. With getLine, we know each time we're inside of this if statement, we've encountered a new line. So that's kind of the benefit of doing it this way, is if we wanted to, we could preserve the new line characters. Say we were going to copy this out to a file, or we wanted to, say, count the number of characters in a line, we would need to know when a line terminates, right? And that's what getLine helps us do. All right, so that was fun. Now let's comment out this cout statement. And our goal now is to read character by character from the word. And our nesting is getting a little deep here. Probably good to break this up and write a helper function for some of these loops. But I'm going to press on for now, but that would be a good exercise to clean this up later. All right, so we want to read character by character from the word. Okay, so word is just a string. There's a few ways that we can do this. We can use a while loop, we can use a for loop, or we can use a for each loop. I'll do the for each loop, which is also known as a range-based for loop, because it's kind of fun and it doesn't require us to make an integer index variable. So a string is a sequence of characters, and I can iterate over that sequence using a range-based for loop. So for char C, so for character C, and then read this colon as in. So for char C in word, I'm going to simply print out C. That's it. And now here's proof right here that we can access each individual character, non-white space character, in the file. But what's beautiful about this solution is we know where the new line characters are, we know where the spaces are, and we can access each individual character, non-white space character. Let me show you one more way to solve this for loop, maybe a little bit more of a traditional way. So a more traditional way to solve this might be to use a standard for loop with an index variable. So int I gets 0, I is less than word.length or word.size. Either one of those will give you the number of characters in a string. And now I can see out word at I or word sub I. Either one of those will work. This will give me the exact same output. So that concludes my demo of file I/O, mostly focusing on the I, working with an input stream. It wouldn't be too hard to expand this to also work with an ofstream, an output stream, and write to a file. In fact, I think I'll do that now in order to show you how you could say, instead of writing this output here, 1 character per line, to the terminal, instead write it to a file. Let's do that really quickly, just for fun. We'll just do it right here. So I'm going to open a new file called outFile. I really should make a function to do this, but it's okay. We'll just do it quickly. All right, so outFile, open. Let's just call it maybe chars.txt. It's going to have all the characters. We should check to make sure it's successfully opened, but since we're opening it for writing, it'll get created if it doesn't exist. So we should be pretty safe here, but always good practice because you never know what can happen. All right, so here we're opening our outFile. Now all I have to do is replace cout with outFile. That's it. OutFile is just like cout. It's an output stream and we can write to it. In fact, if we wanted to, we could even just write this all to one big string using an ostring stream. Ostring stream. O is for output. Okay, the last thing we should do before we forget, we should definitely close outFile. All right, so let's try this again. We shouldn't see any output